Good evening, everybody. Kind of a tough one today. So before we start, I'm going to ask you to look and think. We graphed a lot of abstract relations yesterday. Some came out linear, meaning their graphs are lines. Some of them did not come out linear, meaning their graphs are not lines. And I wrote all the ones we did yesterday here. Here are the ones on the left that were linear. Here are the ones on the right that are not. Here's what I want you to notice. The ones that were linear and the ones that were not, what do you notice about their equations? Is there any clues you can find in these equations that might show you that the graph is going to come out linear, whereas certain equations over here did not? So pause here, gives that some thought. It'll give you a head start on all this, and then we'll get to it. So today I want to teach you how to identify and graph linear functions. Linear meaning their graphs would be a line. Please make this the title on the next page in your math notebook, then close that up. Give me lots of brain power. This is a doozy today. And off we'll go. All right, so yesterday we took abstract relations and just represented them. So y doesn't necessarily stand for anything. X doesn't necessarily stand for anything here. Unlike before, first thing we did with those is turn them into ordered pairs. We called X the input and Y the output. This is not one we graphed yesterday. This is a particularly cool one. I do my usual values for X. If I put X equals -2, then I get output -1/2. If I do X equals -1, I get -1. 0 you can't do. You can't actually have 1 over 0. You can't divide by 0. So this is actually like not going to be on the graph. Not possible to do. If X equals +1, I have 1 over 1, which is 1. X equals +2, 1 over 2, which is 1/2. It's hard to tell from not very many points, but you get a really cool graph when you do this that looks kind of like this. Let me make sure I get it right. -2 up or down 1/2. That's like right there. And -1 down 1, that's there. This isn't enough points to actually see what this one looks like. I'm noticing, but I don't want to take too much time on it. What happens is you get a graph that kind of looks like this. If you did more points closer to 0 and farther, you get this cool graph that looks kind of like this. That's what we did yesterday. And as I had you think about before, some of the graphs turned out linear yesterday and some did not turn out linear. This is the one I just did, and I added it. So here's a bunch of graphs you've seen, and today what I want you to be able to do is be able to look at an equation and tell if its graph is going to come out linear or not. And be extra comfortable graphing functions that are linear. So let's just talk about making a function in general. Yesterday I just gave it to you. I gave you something like this, right? So all you have to do to make an abstract function relation is take an x, some input value x, that you're going to put numbers in for, and do any operation you know to it. You can add to it, you can subtract to it, you can multiply it, you can divide it, you can do an exponent, you can make it an exponent. Yesterday we did absolute value. We did lots of stuff, and you can just take any combo of those things and do that combo. So like you say, okay, I'm going to take a number, I'm going to square it, and then I'm going to add 1. And I'm going to see what I get, y. That's all you do to make a function. And then you go from there. You put in your values and you see what you get. Right? I can just do anything I've ever learned about numbers to the number. Just take an x, do some stuff to it. Maybe I'll take its absolute value and then multiply it by 4 and see what I get out, y, output. So that's what you kind of do. And if y'all pause here, just pick one and do that. Take an x, pick anything off that list I suggested back here, and just make an abstract function of your choice, and then go ahead and make a graph of it. I want you to just see kind of how easy it is. All I'm doing is seeing if I take some x and I do a couple things to it off this list, what happens? What do I get? So go ahead and do that now. Try making one or two, make it up, pick some operations, then make the table, then make the graph. So I took the graphs away, and after thinking about making relations that way. I want to point out some things in the equations that make them linear versus not. Hopefully you're noticing some patterns. This one will turn out linear. So will this. So will this. Won't, 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 won't. Notice what you see here that is different from what you see here. So here's the deal. For a relation or a function to turn out linear, you'll get a linear graph when you take x and add something to it or add it to something. So if you do the addition operation, you'll get a linear graph. So if you do x and add 5, you'll get a linear graph. If you take 6 and add x to it, you'll get a linear graph. Same with negative 6. If you add 2x, you'll get a linear graph. Same if you subtract, which I don't advise doing anymore. I would add the opposite instead. But if you add or subtract, so this would give you a linear graph. So would this. Multiply it by something, or multiply something by it. So this would give you a linear graph. So would this. So even would a fraction. Or divide it by something, but not divide something by it. So that means like this would give you a linear graph, x divided by negative 10, but this would not. Dividing something by it, if x is in the denominator, you don't get a linear graph. That's it. So basically, if you add, subtract, multiply, or divide, you do the basic operations, or any combination of those. So like that too, multiply and add, then you're going to get a linear graph. Here's an example. So here's one here where you'll notice I take x, I multiply it, and I add to it. And that's it. I'm going to get a linear graph when I do this. 1/2 times x plus 3. I'm multiplying, I'm adding. I'm not doing any of the other possible things I could do. This will turn out linear. I'm doing things that make a linear graph. Let me show you to be sure. Input, output. Here we go. I'm going to just input my usual numbers and see what I get out y after I do. So 1/2 times negative 2 is negative 1, plus 3 is positive 2. 1/2 times negative 1 is negative 1/2, plus 3 is positive 2.5. 1/2 times 0 is 0, plus 3 is 3. 1/2 times 1 is 1/2, plus 3 is 3 1/2. 1/2 times 2 is 1, plus 3 is 4. There's my ordered pairs. Head over to my graph, negative 2, 2, negative 1, 2.5, 0, 3, 1, 3.5, and 2, 4. And as I promised, it is going to be a linear graph. I could have done numbers below, I could have done numbers more, so I'm going to go ahead and extend it. Linear graph, I multiplied and I added. As long as you just add, subtract, multiply, or divide, you end up with a linear graph. All right, open your math notebook. Let's start by writing these things down that I mentioned before. So relations or functions will turn out linear if you take x and add something to it, or add it to something rather, or add something to it. Subtract it from something, or subtract something from it. Multiply it by something, or multiply something by it, or divide it by something, but not divide something by it. That is the one exception. If you put x, like 10 divided by x, you will not get a linear graph. But x divided by 10 you would. That's it. Or any combination of those things. That's important to write as well. I don't think I wrote it on here. Let's add it off to the side. Or any combo. So any combination of those things, you can do 2 or 3 of them and you'll still get a linear graph. The key is no exponent, no absolute value, no any other operation. If you do anything else, you typically do not get a linear graph. We're going to be spending a lot of time on linear graphs. You'll get to these later in algebra or in algebra 2. So example, if you take x and multiply it by that, then subtract that, I'll get a linear graph because I multiplied and I subtracted from it. So that would turn out to be a linear graph. I've done 2 of the things on that list. 2 is a common number. You'll often see 2 of them done. Yeah, linear graph. So let's do one to make sure. Here's my equation. Y is 2x plus 4. I'm multiplying and adding to x. So those 2 things together should make a linear graph. Should be no surprise when I get to it. All right, I'm going to do my typical ordered pairs. Input x, output y. I'll do that and that and that and that and that. A good start. That usually shows you enough of the graph to know what's going on. And here we go. -2 times -2 is 4, plus 4 is 8. -2 times -1 is 2, plus 4 is 6. -2 times 0 is 0, plus 4 is 4. -2 times 1 is -2, plus 4 is 2. -2 times 2 is -4, plus 4 is 0. Looks linear to me. X up by 1, y down by 2. X up by 1, y down by 2. X up by 1, y down by 2. I've got that pattern. I'm going to have a negative slope, but I am going to have a line. So here we go. -2, 6, 7, 8 will be up there. -1, 6, 0, 4, 1, 2, 2, 0. And as promised, I do have a linear graph with a negative slope. Down it slopes, and we've got a line. Well, that's how you tell if a graph is going to be linear and how you graph it. The how you graph it part was probably not new. The how you tell if it's linear part was probably. So please, 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 if you would, go back and watch this again if that part really wasn't clear, because I want you to be able to look, as we move forward, I want you to be able to look at an equation and be like, yep, that's going to be a linear graph, or no, that's not going to be a linear graph real easily. I want that to just be like second nature. So give it another watch if you need to. If not, you're all set, and I will see you tomorrow.